All right, so today, by the way, having a long weekend like this, I feel like it's hard to get going, right? To remember what we've learned. But you need to understand there is a quiz on Friday, right? You need to remember anything that we've learned from chapter 3. So like any of the definitions, like what's the definition of a corresponding angle, alternate interior angles? You know, knowing the difference, like here I have two lines being intersected by a transversal. Knowing that 2 and 3 right here are same side interior angles, but are they necessarily supplementary at that point? No. When would 2 and 3 be supplementary? In that diagram, what would make them supplementary? Trevor?
Parallel lines.
Yeah, if I changed it, so I had parallel lines, all of a sudden 2 and 3 would be supplementary. So knowing the difference for when my lines are parallel and the lines are not parallel, huge stuff that you need to know. So let's go through and let's see if we can remember how to do these. All right. So it says state the theorem of Postulate that is related to the measures of the angles in each pair, then find the unknown angle measures. Okay, so we have to find the unknown angle measures. So looking at this, my friends, what do I have marked in my diagram? What's given to me in my diagram? This is not meant to be hard, guys. What's there? Yes?
2 parallel.
Yeah, I have parallel lines. And the moment you hear parallel lines, your brain starts going tick, 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 tick. All right, corresponding angles are what? All right, alternate exterior angles are what? Same side interior? Supplementary. Alternate exterior congruent. We know that right away. So the moment I see those parallel lines, that's what's running through my head. So when I'm looking here and I said, all right, the measure of angle 1 is 120 degrees and the measure of angle 2 is 6x. It says, find what postulate or theorem did I use to be able to solve for my unknown. What do I know? Yeah, I have a pair of alternate exterior angles. Well, what's so special about alternate exterior angles if I have parallel lines? They're congruent. So we know angle 1 and angle 2 are congruent. So I know the measure of angle 1 is equal to the measure of angle 2. Now, guys, do I have to do a lot of math right here then? I'm supposed to find the unknown here. But isn't that the fact then I know the measure of angle 2 is just 120 degrees? Do I really have to worry about solving for anything? Because if they're congruent to each other, I know one's 120, the other one automatically has to be 120. And the theorem that told us that was our alternate exterior angles theorem. You could write it out, or you could do it like I like with the conditionals. If parallel lines, then alternate exterior angles are congruent. Excellent. All right, let's look at the next one. We got 3 and 4 this time. 3 and 4. Guys, what do we know about 3 and 4? What's their relationship? They're what? They're congruent because? Yeah, they're alternate interior angles. If I have parallel lines, then alternate exterior angles are congruent. So that would be your alternate interior angles theorem. Or you could say if parallel lines, then alternate interior angles are congruent. But now I have to find my unknown angles. So that means I have to find the measure of angle 3 and the measure of angle 4. But if they're congruent to each other, what do I know about their measures? They're the same. So I can set them equal. So I can go 50x plus 20 is equal to 100x minus 80. So I'm going to end up moving the 80 over. So I get 50x plus 100. Oops, yeah, that's right. Make sure my math is right. Equals 100x. Subtract 50 from x from both sides. Guys, you get x is equal to 2? Yeah, then do I have to plug it into one of them or both of the angles? One, right? Because we already know they're congruent. So you just plug it in. The measure of angle 3 is just going to be 50 times 2 plus 20. So we're going to end up getting the fact it's 120 degrees as well. Which also means the measure of angle 4 is 120 degrees because we know alternate interior angles are congruent. What do you guys think? Easy schmeezy? It's not bad. Now today we're going to take a little bit different. All right. We're going to use the fact that we're proving the lines parallel. Before, we've always started if parallel lines. Guess what we're going to end instead? Then parallel lines. So we're going to switch things around. It's not hard if you know how to do a converse of something, right? So look at this very first one. It's a postulate. The converse of the corresponding angles postulate says the following. If two coplanar lines are cut by a transversal so that a pair of corresponding angles are congruent, then the two lines are parallel. Now, you guys know well enough that I don't really love the title of this postulate, but I do think we can abbreviate it pretty well. What if I did this? Corresponding angles are congruent implies parallel lines. Isn't that very similar to what we would have done, but just literally did the converse of what we had last week? Because last week we said if parallel lines, then corresponding angles are congruent. This time it just flips the other way around. Notice what's marked differently. Where I start is different. This time I mark the angles congruent first. As a result, I then know my lines are parallel. What was different up above? What was different up above? My lines were what first? My lines were parallel first, then I could work with the angles. It just switched which one you're looking at first. Now, think about it. If I couldn't prove the converse angles postulate, there's no way I'm going to be able to do its converse either, right? We just know it's going to what? Be true. But it doesn't mean that I can't use that for other ones. Now, a few other ones that we have to learn. All right, this is a weird postulate. It doesn't show up often, but when it shows up, it's like very useful. All right, so it's called the parallel postulate, and this is what it says. Through a point P, not on line L, there is exactly one line parallel to line L. All right, what in the world is this talking about? Let you write that down first and then show it to you. Through a point P, not on line L, there is exactly one line parallel to line L. All right, guys, here's what we're doing. The diagram off to the right really shows it all. Everyone see line L on the bottom? Okay, here's my question. Can I draw a line parallel to line L through point P? Even though it wasn't drawn there initially, do we know we can draw one in? Because everything's just made up of points. We know that's true. Now here's my question. Can I draw another line through point P that's parallel to L? No, there's no way you can do it. You can try as much as you want. Like, okay, if you tilt it, it's no longer what? Parallel. Because it has to be the same distance apart from each other in the same plane. So there's no way. So the thing is, I could put like another point right here. Let's call that point B. How many lines through that point B would I have parallel to L? You're still going to only have one. That's basically the idea when you're working with it. It can't change. Make sense? So it's like you just can't draw it any other way. Now, why is that helpful? Proofs. That helps us on proofs. It's really what it does, especially even with triangle stuff. All right, now let's go ahead. Now, guys, we're going to have proofs. Proofs are also going to turn really hard. Did everyone hear me on this? Proofs are not going to be hand-fed anymore, so you're going to have to really attempt them, and if you're not getting them, you're going to have to come in. So these are very important theorems for your proofs. So take the time to review your past stuff. I'm sure most of you over the weekend did not take the time to review all of your old geometry notes, but it's going to be critical that you are. So let's start going through here. So these are all theorems that are going to prove lines parallel. First one, converse of the alternate interior angles theorem. If two coplanar lines are cut by a transversal so that a pair of alternate interior angles are congruent, then the two lines are parallel. And how many pairs do I need? Do I need both pairs of alternate interior angles being congruent? No, you only need one pair. So how would you say that? Well, just the converse of what we did the other day. If I have alternate interior angles are congruent, then I have parallel lines. I like the abbreviation of it. It's a lot faster, right, as a conditional statement using our arrow. Now, guys, what do you think it's going to be for the converse of the alternate exterior angles theorem? If two coplanar lines are cut by a transversal, so a pair of what? Yeah, alternate exterior angles. That should be an angle symbol, and that did not look like it. angles are congruent, then the two lines are parallel. So again, I need to know where I'm starting, where I'm ending. If I start with angles, I end with parallel lines. If I start with parallel lines, I'll end with angles. It's just really which one is my hypothesis? Which one do I see first? And sometimes a combination of the two will be used in a theorem. And then the last but not least, it says the following. The converse of the same side interior angles theorem. If two coplanar lines are cut by transversal so that a pair of same side interior angles are same side what? Supplementary. Then the two lines are parallel. Oops, I realized I just forgot to fill in my parenthesis one up above. I'll let you write that down first and then we'll fill in the part. All right, quick fill in. I bet you guys can figure out what to go in the parentheses. The first one is just going to be alternate exterior angles are congruent, implies parallel lines. The bottom one is just same side interior angles are what? Supplementary. Angles are supplementary. Then we have parallel lines. Now, today alone, you had 2 postulates and 3 theorems. Do you think those are important enough to memorize? Yeah, we're going to use those a lot. So you want to make sure that you have them memorized. But that's the new information. Now we just got to practice. Sound good? But isn't it easy to understand, like, that's just the converse of what I already know. That makes sense. And these are true converses, so it works out great. Now, a couple things that I noticed when you guys were doing homework on your own. If you're proving a theorem, you cannot use the theorem inside of it, okay? A few people didn't use their notes the other day on lesson 3.2s where it was prove that same side interior angles are supplementary. And we had it in our notes, so you could just basically copied almost everything from your notes. But a lot of people just did given, and then they put the last one like, because if parallel lines and same side interior angles are supplementary. That doesn't work because you're trying to prove that theorem. You can't use the theorem in the theorem you're trying to prove. So be very careful with that. Now, with these, we're probably not going to go over every example. Did everyone hear me on this? We might actually, you know what, we'll be pushing out of time. But with these, you've got to make sure you have the correct information. You got to make sure that the hypothesis statement is true so I can come up with the fact the lines are parallel. So here's the directions. It says, tell whether lines M and N must be parallel from the given information. If they are, state your reasons. Hint, the angle measures may change for each exercise and the figure is for reference only. Basically, it's just to give you a rough idea what you're looking at, right? So does that mean remarking stuff up, erasing? Yeah, redrawing your diagram? Definitely. So on the very first one, let's look at this one. I tell you that angle 7 is congruent to angle 3. So what am I going to do on my diagram? I'm going to mark in my diagram that they're congruent. The moment I do that, what does it scream out to you? They're alternate interior angles. Well, what's so special about them? Well, if they're congruent, what happens? My lines must be what then? Exactly. That's exactly what you do. So remember, these are alternate interior angles. That was your huge hint that this would probably work. So excellent. So are they parallel or not? What are you guys going to say? Yes. Why? Because if alternate interior angles are congruent, then parallel lines. Do you guys realize this is actually shorter than writing out the theorem name, right? The converse of the alternate exterior angles theorem. Write this out. It's much better. Now, you could say this, though, converse. I'd say alt int angles theorem. It's about the same amount of time. Killer people. But I will take either one of those as the answer. I prefer the conditional statement. Now, was that really that hard? No. All right, let's try the next one. Okay, look at example 2. They go, the measure of angle 3, they tell us is going to be 15x plus 22. So I know this one is going to be 15x plus 22. They tell us the measure of angle 1 is 19x minus 10, and they tell us x is equal to 8. All right, guys, what am I going to use that x equals 8 for? What do I need? What do I hope to show? I want to show, if I could do this right, I can show, if I can show 1 and 3 congruent, I have a pair of corresponding angles. If they have a pair of corresponding angles that are congruent, are my lines parallel? So don't I have to plug in 8 into both angles to see if that actually works? So let's do that real quick. So here in the measure of angle 3, I'm going to plug it in. I got 15 times 8 plus 22. Someone do that real quick for me. 15 times 8, is that 140? 120? 120? Thank you. 120 plus 22. All right, so that gives me 142 degrees. I need to check with measure of angle 1 if that's the case. So 19 times 8 minus 10. Isn't that 152 minus 10? Double check my math. So it's 142. All right, so what's so special about those two angles? They're equal, right? If they're equal in measure, that means, oh, look, they're congruent to each other. Do I have parallel lines? So my answer, yes or no? Yes. Yes. Because, what do we have, you guys? If corresponding angles are congruent, then I have parallel lines. Notice I don't worry about the title of things very much that way. Okay, excuse me. All right, next one's my friends. Let's try this one. Let's look at 3. I'm going to erase my diagram. They told me angle 7 and angle 6 are congruent. Will that let me know if those lines are parallel? M and N are parallel. What do you guys think? Well, first of all, what type of angles are 6 and 7? Same side here. They have to be what? Supplementary. The problem is, could I have it drawn just slightly weird, like this, and have 7 and 6 like that? And so they're both acute angles. Yeah, they're congruent to each other, but would they be supplementary? No. So in this case, do I have enough information? No. So in this case, we'd say not able to tell if parallel. Okay. Same side interior angles need to be what? Supplementary. Now, what if they're both 90 degrees? Would that work? But remember, as long as I can show one bad counterexample, can I throw it out? Like, so long as I can show it, we're good. All right, yes, sir.
Do you need to state that the same side interior angles?
Not really on there. That's just for you to know. I was just making sure we know why. But make sure always be able to explain yourself. All right. I'm not too worried about you guys on number 4. So we're going to skip number 4. I'm just going to let you know the answer is yes, by the way. Okay. So go and see filled in notes. This is very similar to number 2. Similar, but not the same to number 2. So you can use that as a reference when you're doing your homework. Okay, see your filled in notes online. All right, let's look at the next one. Let's look at example 5. It says the measure of 8 and 4. So I'm looking at 8 and 4. So up here I have 8 and 4. Those are what type of angles? Exterior. So I need them to be what? Congruent. So are they? Let's check real quick. So I plug in the 9. So I get 6 times 9 minus 1. That's going to be 54 minus 1, which is 53 degrees. I go here. I get 5 times 9 plus 3. So that's going to be, what, 45 plus 3? That's 48 degrees. Guys, do I have what I need them to be? Yeah, no. And I'm going to tell you the reason why, because I want everyone on the same page. The angles need to be congruent, right? Since they are alternate exterior angles. And they're not. So are they parallel? No. That's how simple these really can be. All right, let's look at, try to say, yeah, no, okay. I think 6 is actually really fast. Guys, it says angle 5 is congruent to angle 7. Are the lines M and N parallel? What do you guys got? No, yes? Okay, a little bit louder then. Which one is it? Yes. All right. Why?
Because of the corresponding.
Yeah. Yep. Not corresponding angles theorem. No, it'd be converse of the corresponding angles theorem. All right. So if corresponding angles are congruent, then parallel lines. If you don't want to say that, you'd have to say converse of the corresponding angles postulate. Either one of those are valid reasons for B. But remember, converse is a different start. The converse means you end with what? The parallel lines. The initial ones, you started with what? The parallel lines. So that's why you have to be really careful because it's a different ending and starting spot. They switch.
So
yes.
As long as we know like corresponding angles, like as long as we write that out, we don't have to know the name.
I don't like the name of it.
So like.
But you might have to like on your quiz or something like explain what it means. But like if you know this, it's pretty simple, right? Yeah. A nice thing is the names do go with what the words say this time. Sometimes they don't make as much sense, but these times they really do. All right, guys, how about 1 and 5? Oops, as I go too far. They say angle 1 and angle 5 are congruent. Are my lines parallel? Yes, exactly. So yes. No idea. So I'm not answering it. All right. So this one be yes because what do we have? If alternate, isn't this our exterior angles? Double check on here. Alternate exterior angles are congruent, then parallel lines, right? Or we'd say the converse of what? The alternate exterior theorem. Alternate exterior angles theorem. I like the first part. It's easier. All right, how about number 8? How about number 8? Let's see what number 8 tells us. On number 8, it tells you that 6 is x plus 10 degrees and that 2 is x plus 15 degrees.
No, they're
Alternate, yeah.
Yeah, alternate interior angles. So you can tell right away if x is going to be the same thing that they can't be true because.
I need more, right?
Yeah.
Yeah, when I look at this, they're supposed to be congruent to each other, right? If I have parallel lines, 2 and 6 are alternate interior angles. Alternate interior angles need to be congruent. Look at the two of them. Oops, I keep going too far. I'm getting like really excited with my scrolling lately. All right, with it, are those equal to each other? No, so they're not parallel. In order for that to happen, I'd have to have more information than that. So we're like, all right, they're not parallel. Even though I have alternate interior angles I'm talking about, they're not congruent to each other, so they cannot be parallel. Good stuff. All right, let's do proofs because this is everyone's favorite, right? Now, guys, these proofs aren't bad. If you remember transitive property a lot, it makes your life really easy. But you also have to use your given information, so marking up your given info. One of my biggest pet peeves is when people don't use like the numbers they give you either in the proof. So on this one, I want to prove, my whole joy in this whole theorem is I want to prove that these two lines, L and M, are parallel, which means I have to show either a pair of congruent angles or I have to show a pair of supplementary angles or something for that to happen. Well, guys, look at lines L and M. What two angles would I use that has a common transversal that would be for L and M? Wouldn't I try to use 1 and 2? So somehow I need to show that 1 and 2 are congruent to each other. That's really going to be my goal. But I got to start with the fact that it's given that angle 1 is congruent. I'm going to use a different color pen here. That angle 1 is congruent to angle 3, and it's given the fact I have parallel lines. So we're going to have to use those to our advantage. Well, guys, what's my very first reason? And you're given, you have parallel lines. So in your head, you start going, all right, do I have corresponding angles congruent? Do I have alternate interior angles congruent? Do I have alternate exterior angles congruent? Do I have same side supplementary? But what I'm looking at, look at what the authors told you to choose next. They go, angle 2 is congruent to angle 3. Why do I know that? Hey, Trevor.
They're alternate exterior angles.
Yeah, and my lines were what? parallel first. So I'm going to use the fact my lines are parallel first. So I'm going to like, if I have parallel lines, then my alternate exterior angles are congruent. Now, again, here's the or. If you want to write out the alternate exterior angles theorem like this, would I give you full credit? Yes. I just like the phrase better. I want you to think about, I started with parallel lines. Now, again, we're sitting there like, I'm kind of stuck. Great. So when you're stuck, where do you go back to? You go back to your given. So I get angle 1 is congruent to angle 3. And that's my given. Now, guys, look at 2 and 3. Is there any way I can combine those to get 4? Yeah. Careful. You can't use substitution with a congruency symbol. So what's the only one that works for that?
Oh.
Transitive, right? So it's going to be your transitive. Very good. Remember, substitution only works with equal signs. If we do anything that's similar to that with the congruency symbol, it has to be the transitive property. All right, so the transitive, and really we're just connecting the angle 3's, right? Connect it out. Now, look what I have here. Do I have now the fact that angle 1 and angle 2 are congruent? Now, ignore line R. It's not helpful anymore. But what do I know about angle 1 and angle 2? What type of angles are those? Corresponding angles. If I have corresponding angles that are congruent, what do I know about my lines? They're parallel. And that's exactly what I'd say. If corresponding angles are congruent, then parallel lines. Or that's called what? The converse of the corresponding angles postulate. Oh, I like that better. But was that really that impossible to do? Now, the next one's harder, but of course I'm helping you with the harder one, all right? But a lot of times transitive property is going to be very helpful. Also, use the angles that they have marked for you. Use the fact, if I give you parallel lines, no, you're going to use something that's probably congruent or supplementary to work with these. But now let's have a little bit more fun, okay? When I say a little bit more fun, look at all those lines. Isn't that such a great time? I have angle 1 is going to be congruent to angle 4, so guess what I'm going to mark in my diagram, guys? And then we're going to prove, we also know that angle 3 and angle 4 are supplementary. And I want to prove that line L is basically parallel to line M. Okay, so line L is parallel. I want to show that these two are parallel to each other. All right, looking at it, it kind of looks it already, doesn't it? But let's see what we can do with this. Now, there's a lot of different approaches we could take on this problem. I'm going to take you on a little bit more of a mathematical approach, if that's okay with you guys. So I'm going to do a little more of the algebra way of showing things. But you guys should probably be pretty good at this. I have a feeling it's not going to be too bad. So what are we going to start with, guys?
Yeah.
Which one do I start with? Does it matter which? Does it? All right. So, okay, I'm going to start with the first one, but you know what? I'm not going to do anything with it for a while. So I'm just going to go, okay, given, great. I'm basically not going to touch that for a long time. Just leave it alone. But I do know I can go back to the given again. So I got angle 3 and angle 4 are supplementary. Now, guys, if you know they're supplementary, what goes into your head next? They add up to what? All right, so can I do that? So, yep, the measure of angle 3 plus the measure of angle 4 is equal to 180. And that's just definition of supplementary angles, because that's what they tell us. Now, wouldn't it be nice? Wouldn't it be nice if I can show angle 1 and angle 2 are supplementary? Wouldn't that be really nice? Because if I could show angle 1 and angle 2 are supplementary, do I know that line L and line M are parallel because they're same side interior angles? So guess what my goal is? Because even how it's marked, I have 1 and 2, like, ooh, those are same side interior angles. I want to show that they're supplementary. There must be a way that I can physically do that. It'd be really fun if I could take this equation, the measure of angle 3 plus the measure of angle 4. And would it be nice if I could replace angle measures in there? Yes, Connor. Yeah, I'm going to use some vertical angles theorem and then just change up some stuff I need, right? So guys, can't I use the fact that this is true? What do you guys think? Yeah, I'm going to use that next because I'm kind of stuck. So I'm going to go back to that. I'm going to go, all right, angle 2 is congruent to angle 3 because of the vertical angle theorem. Vertical angles theorem, excuse me. If two angles are vertical, then they are congruent. And how did I get that? Oh, I got that from the diagram. And you don't have to say diagram right there, but that lets you know where it came from. And then I really would like to substitute it into that equation. So I know I'm going to have to change it to equal each other. And that's just definition of congruent angles, right? Guys, can I substitute it in now? So I'm going to sit there and go, okay, here, I can replace 3 with 2. So I'm going to go in the measure of angle 2 plus the measure of angle 4 is equal to 180. And that's the substitution property. Now, wouldn't it be really nice if I could replace angle 4 with angle 1? Wouldn't that be really nice? I almost can't. What's the only thing I need to do with that one? Do I need to say they're equal in measure to each other first? So yeah, so I go back here and go, all right, this is all the way back because I haven't touched it from number 1. I know they're equal in measure. And that's just definition of congruent angles. Could I do substitution again and go the measure of angle 2 plus the measure of angle 1 is equal to 180. And again, that's substitution property because I'm working with an equal sign. Now guys, what do I know about angle 1 and angle 2? They're what? All right. So angle 1 and angle 2 are supplementary. Isn't that the definition of supplementary angles? Unless I've changed the rules on you, right? So that's the definition of supplementary angles. So hey guys, we just showed that they're supplementary. Oh wait, aren't those same side interior angles? Are those same side interior angles? So if same side interior angles are supplementary, what do I know about my lines? They're parallel. So we're there. Now this was a long proof. Do you really think I expect you to do a perfect 10-step proof yet? A 4 or 5, maybe a 6-step proof, but not 10. Okay. No, there's a reason why I did this one with you, all right? But you guys can get it. So we know that line L is parallel to line M by the fact of same side interior angles are supplementary. Then I have parallel lines. Now that is a little bit of a kicker, a little bit hard, right? All right, so here's what you need to know. Homework tonight. Have bookwork and you have one of those homework supplements online worksheets. One of the problems on the homework supplement literally says use lesson 3-2 notes. It's proofs. The homework supplements are always going to be practicing proofs. So for one of them you're using lesson 3-2. The other one you're going to be using lesson 3-3 and maybe 3-2 stuff together. Does that make sense? So it's just 2 proofs on the homework supplement. I don't think I have a third one on there. And then you just do the stuff from the book. Is that clear for homework? All right, again, I don't expect you to do a perfect 10-step proof yet. Don't worry, but I do want you to start attempting them no matter what.